Okay, start with okay too much. There we go. Velocity and speed. So as quick definition, speed is just how fast you are traveling. I never remember if traveling is 1L or 2, but I think I looked it up recently and it's actually 1 most of the time, but acceptable is 2 under a different spelling system. I can't remember which is which. It might be American versus British. Anyway. And velocity is your speed and direction. If we're talking the mathematics behind it, let's say the position vector is r. That'll make more sense after we cover chapter 4, but for the moment we'll just call it r instead of x or y. Then the average velocity is just found as the change in the position divided by the time, and the instantaneous velocity would be the derivative of the position with respect to time. Right, if we're talking about what this means in terms of a graph, the velocity is essentially the slope of the position versus time curve. Alright, if we want the speed, that's just essentially the absolute value of the velocity vector. So you'd be looking at something like dr dt inside absolute values. Let's see. So if we're looking at some kind of position versus, well, actually we wouldn't be looking at this. If we were looking at it backward, an xy graph, and we had some r1, and it moves to some r2, then delta r would be what takes you from one to the other, and if you divide that by time, that's what's giving you your velocity. If we make the change in those really, really small, so r1 and r2 are crazy close together, then our vector going between them would just be dr, showing you the tiny change, and you could do dr over dt and find your velocity again. A couple interesting questions. Does the speedometer of a car give you speed or velocity? That one's kind of obvious. It's going to be speed, it's why it's called a speedometer. It tells you information about how fast you're going, but not particularly in what direction. It might tell you forward versus backward, but that's about the best you can hope for. It's not going to tell you you're headed west or you're headed north. You'd have to add a compass to get the full velocity information. The other thing. Is it instantaneous speed that a speedometer tells you, or average speed that the speedometer tells you? That one's harder to tell, but notice if you change your speed by pushing down on the gas pedal a little harder, pretty quickly, almost immediately, will increase in speed. So that's very suggestive that it is the instantaneous speed, and it certainly is far closer to instantaneous speed than it is to average. Okay, so that's some definitions and a couple equations that we'll need to use in the future. Another way of looking at velocity, which we'll be using in this chapter a lot, is something like dx dt, so it's not really a vector anymore because we're just dealing with 1D motion. But when we get more properly into how it's defined, it will be dr dt, where r is the position vector. Okay, that's going to be it for this. I'll see you in the next one.